In this tutorial, we will be discussing density. The density of a substance is the ratio of its mass to its volume. We calculate density of a substance by dividing the mass of a given amount of a substance by its volume. For example, a sample of a liquid has a volume of 22.5 milliliters, so that will be the number on the bottom, and a mass of 27.2 grams. So it's mass over volume. 27.2 divided by 22.5 is 1.2. It's actually 1.20889. But because each of these numbers have three significant figures, we're going to round it off to 1.21. The units are whatever units that the mass and volume are in. So it's going to be grams per milliliter. One important note to make is to make sure that your units always match up. So if you're given a mass in kilograms, yet a density in grams, you need to make sure that you convert it appropriately to get everything in the correct units. We can use density of a substance as a conversion factor as well between the mass of a substance and its volume. For example, for a liquid substance with a density of 1.32 grams per centimeter cubed, that conversion factor becomes 1.32 grams is equal to 1 centimeter cubed. We've talked about conversions previously, and we always talked about putting the number over 1. Because of this slash here, that unit that's underneath the slash goes with the number 1. So here's the 1 with the centimeters cubed. What volume should be measured to deliver a mass of 68.4 grams? So 68.4 grams over 1. Look for grams. Whatever's on top goes on the bottom of the next one. Grams is here at 1.32 is equal to 1 centimeter cubed. So 68.4 divided by 1.32 comes out to be 51.8. There's three significant figures, so I'm going to keep it at three figs. Centimeters cubed. The grams cancel out, and you're left over with centimeters cubed. You could either use density as the conversion factor, or as previously noted, as the equation density is equal to mass over volume. So let's do a few more practices with these. Find the volume in liters. Notice that the density is given to you in milliliters. A 54.50 grams of liquid with a density of 0.9502. I'm going to use this as a conversion factor again. So 0.9502 grams is equal to 1 milliliter. So I have the starting number to be 54.50 grams. I have grams on top, so I'm going to put grams on the bottom so that they're catty corner. The number of 0.9502 goes with the letter grams, the unit grams. That's equal to 1 milliliter. It's asking about liters. Milli means 1,000. So milliliters will be on the bottom because we want them catty cornered. The grams cancel. 1,000 goes with milliliters because milli stands for 1,000. Is in 1 liters. Another way to have put that is 1 milliliter is equal to 0.001 liters. So 54.50 divided by 95.02 divided by 1,000. I want 4 significant figures in the final answer. 0.057, that's supposed to be a 7, 36 liters. Once again, notice that the density was in milliliters, but the volume that they asked for was in liters. I could have put this in the equation instead by going density is equal to mass over volume. So 0.95 54.02 grams per milliliter is equal to 54.50 grams over X. Solve for X, and that comes out to be 57.356 milliliters because of the milliliters here. It would be 54.50, rearrange the equation, put X on both sides to get it on the top, and then divide both sides by 0.9502. And then once you find your X, once you find that answer, you're going to have to divide it by 1,000 to get it into liters. Alright, so what if they don't give you the volume, but they give you some other information? A piece of wood that measures 3 centimeters by 6 centimeters by 4 centimeters has a mass of 80.0 grams. What's the density? When they give you the density in the question itself, you can use it as a conversion factor. If they don't, that means you have to use the equation. So, before I do anything else, I have to figure out what the volume is. By doing length times width times height. So 3.0 times 6.0 times 4.0 all comes out to be 72. Centimeters, centimeters, centimeters means it's centimeters cubed. That's going to be our volume. That's going to be our bottom number. They give you 80.0 grams as the mass. That'll be my top number. I have 3 significant figures here, and I have 2 here, which means my answer is going to have 2 significant figures, which gives me 1.1 grams per centimeter cubed. We'll try one more practice problem for this video. Gasoline is a nonpolar liquid that will float on water. 450 grams of gasoline is spilled into a puddle of water. If the density is 0.665 grams per milliliter, what's the volume of the gasoline that's spilled? Once again, because of the fact that it's given me the density in the question, I could actually use that as a conversion factor. Just for those who want to use the equation instead, I'm going to show you how to do that this time. So, density is equal to mass over volume. So, that means 0.665 grams per milliliter is equal to 450 grams over the volume, X. You can't have X on the bottom when you're trying to solve for it, so I'm going to multiply both sides by X. The X cancels on this side. Now I want to get X by itself. I'm going to get X by itself on the left-hand side, so I'm going to divide both sides by 0.665. That gives me X is equal to 450 divided by 0.665. The grams cancel. I'm left over with milliliters. Comes out to be 676.69 milliliters. This number has 2 significant figures because there is no decimal. This number has 3 significant figures. That leading 0 does not count. Therefore, my final answer is going to have 2 because we're dividing here. So that gives me a final answer of 680 milliliters. Once again, I could have done this as a conversion factor by saying 0.665 grams is equal to 1 milliliter by using the density here. 450 grams. Grams are on the top, so that means I want grams on the bottom. Here's my grams, 0.665 0.665 is equal to 1 milliliter. So 450 divided by 0.665, once again, is this number, 676, which rounds off to be 680 milliliters. Notice either way you're dividing 450 divided by 0.665. It's just two different ways of looking at the question. And that's how you perform density equations.